In this lesson, we're going to look at how to create partial fractions, which is basically taking a fraction that's shown to you here on the left and rewriting it as it's given to you on the right. And some things that you have to do with that. These are the tips and tricks of the trade for this particular guy. Some of these can just be really confusing and difficult, but hang in there. It'll all make sense, okay? Some rules. Number one, the degree of the numerator needs to be less than the degree of the denominator, okay? And if that doesn't happen, you have to use long division. Number two, you need to factor the denominator as completely as possible, as far down as you can. Use the quadratic formula if you need to, but don't factor it down to square roots. You need to have rational numbers as part of your factors. Irreducible quadratics are okay as long as the numerator is linear. Each factor that you come up with in the denominator will be part of the partial fraction. As you can see up here, if we were to factor this, this would be x minus 2 times x, and we have x, and we have x minus 2. All numbers in the partial need to be 1 degree less than the denominator, and again, you can see that up here. We've got an x for the denominator and nothing, and an x and a nothing, okay, for the degree. And you can check all of these by graphing. You can graph the original function, graph what your sum is, and they should be identical. And you can even look at your table of points and determine whether or not they're the same thing. So on this particular problem, what we want to do is just look at what the terms of the partial fraction decomposition might look like. It's really not that bad. It's already factored for us. The denominator is already factored. So when we solve this guy out, we're just simply going to say that this is equal to a over x plus b over x squared plus c over x cubed. Okay, that takes care of all of those factors right there because x cubed is x times x times x. So we have to represent all those different factors plus d over x plus 3 plus ex plus f over x squared plus 1. And that's how you're going to handle the irreducible quadratic. We have to have that linear term in the top. Okay, so this is how the different terms of the partial fraction decomposition would look. We're not going to solve this one. He would be a little bit on the nasty side. All right, so here you go. Find your partial fraction decomposition. The first thing to check is the degree of the denominator less than the degree of the numerator. In this case, it is, so we're good to go. Then we just need to factor. So this guy's going to actually factor to x times x, and then what's it going to be? Well, what times what is 15 that makes negative 2, and that's going to be negative 5 and a positive 3. So when we look at this guy, what we're going to say is we're going to have a over x minus 5 plus b over x plus 3. Okay, so here's how your partial fraction is going to set up to look like. Well, what we want to do is basically clear out our fraction. If we're working with equality, we're saying that these two things have to be equal. And if those two things have to be equal, I just want to look at the numerators only. So I'm going to combine this side so that my denominator down here matches my denominator over here. And when I do that, I have to multiply this side by x minus 5. And I multiply the a side by x plus 3. Okay? What that gives me then, that gives me a new looking problem, which looks like this. It looks like a times x plus 3 plus b times x minus 5. And remember now that the denominators are the same, we can set the numerators equal to each other. And so it's going to look like this, 5x minus 1. There's several different ways to do it. The easiest way that I've seen, and if you have an easier way, you let me know. You could do a matrix, you could do a whole bunch of stuff, but the easiest thing is to just look at zeros. What makes zeros for this particular problem? And one of the things that makes zeros is when x equals negative 3. And the other thing that makes a 0 is when x equals 5. Those are the two ways that you get a 0 here. The reason I picked these, and we'll go with the negative 3 first. When I work out negative 3, I get a times negative 3 plus 3. That makes 0. plus b times negative 3 minus 5 equals 5 times negative 3 minus 1. Solve this out, and what's going to end up as the only variable is going to be b. So a times 0 plus negative 8 times b equals, and this is going to be negative 15 minus 1, negative 16. So guess what? B equals 2. B equals 2. All right. The gray guy then, we'll solve him over here. The gray guy is going to be the same thing. A times 5 plus 3 plus b times 5 minus 5 equals 5 times 5 minus 1. Sorry, that's a little crowded. And what I end up with is the b goes away now, and I've got 8 times a equals 25 minus 1, which is 24. So what does a equal? 3. So my partial fraction decomposition then, my solution is going to be 3 over x minus 5 plus 2 over x plus 3. And this guy right here is your answer. For this particular one, we've got to do some factoring first. So go ahead and factor the denominator. You can factor x out. That gives you x squared minus 4x plus 4. And then factor that. So this is going to be x times x minus 2 times x minus 2. Okay? So my factors then are going to be a over x plus b over x minus 2 plus c over x minus 2 squared. I have to list both of those pieces. Okay, and then multiply by what's missing. So the middle term needs an x minus 2. The first guy needs an x minus 2 squared. Middle term needs an x, and the last term needs an x. And so this is how it looks. And then we just write this all down, because now we've got the numerator. This numerator here is the exact same as this numerator here. Now it's going to look really weird, but when you set it up, you're going to have a times x minus 2 squared plus bx times x minus 2 plus cx equals negative x squared plus 2x plus 4. And again, we're going to pick zeros here. And I'm going to get a 0 when x is 2 and when x is 0. Okay? I get the 2 at this point and this point, and I get a 0 at this point and this point. So something should always cancel out. And substituting in, we'll do the 2 first. I'll do it, let's see here. I'll do the 2 first in gray. So a times 2 minus 2 squared plus bx times 2 minus 2 plus c times 2 equals negative, and then 2 squared plus 2 times 2 plus 4. And when everything cancels out, you're going to be left with a number that works out pretty well. So the a part goes away, and the b part goes away, and I've got 2c equals negative 4 plus 4, so that part goes away, and I get c equals 4. That's the first guy right there. And then do it all again, and this time we're going to put that 0 in. So looks like this. Okay, and again, a bunch of stuff cancels out. This guy's going to go away, this guy's going to go away, and that leaves me then with just a 4a equals 4. So a is equal to 1. And as I'm looking at my problem here, I notice this guy actually should be c equals 2. So I'm just going to, you want to erase. We'll just make that guy a 2. Now to get this last guy, we're going to take a little algebraic trick here, and we're going to assume that we know what's going on. And so I'm going to just resize this image real quick. And what we're going to do is we're now going to choose a different value for x, a totally different value, and it needs to be something simple that we can use, like 1 or 0 if you haven't used 0, or -1, but some small value. And also, we're going to, while we use x equals 1, we're also going to use that a is equal to 1, because that's what we just solved for. And we're going to use that c is equal to 2, because that's what we just solved for. And then we're going to take and we're going to substitute all these things back into our problem, and the only variable that we'll have left will be a b. So I'm going to have 1 times 1 minus 2 squared plus b times 1 times 1 minus 2 plus c times 1. And that's going to equal -1 squared plus 2 times 1 plus 4. So we're just going to solve this guy down, and -1 squared is -1 plus 2 is -1 or is 1. So -1 plus 2 is 1 plus 4. So this guy over here is going to be equal to 5. And then on the left, we're going to have -b. It was 1 minus 2 is -1, so it's -b plus 2. And then 1 minus 2 is -1 squared is 1. So it looks like this. And so for this guy, we're going to have b plus 3 equals 5. Negative b plus 3. So negative b equals 2. So b equals -2. And that's how you solve these partial fractions out. So what's my partial fraction decomposition? I'll write it in red. 1 over x plus -2 over x minus 2 plus 2 over x minus 2 squared. All right, find the partial fraction decomposition. So first things first, factor the denominator. And on this guy, what I'm going to do is kind of factor by grouping. I'm looking at this first term and I see I've got x squared that I can pull out. And when I do that, that gives me x minus 1 plus x minus 1. And that also factors out. I can factor out, so I'm going to have x squared plus 1 times x minus 1. And so my partial fraction set is going to be ax plus b over x squared plus 1 plus c over x minus 1. And, figure out what you're missing. This side's missing x squared plus 1. This side's missing x minus 1. And we've got our setup here. So x squared plus 4x plus 1 equals ax plus b times x minus 1 plus c times x squared plus 1. And look at your zeros. And again, the zeros are easy to find. On this particular guy, we're going to be really interested when x is equal to 1. And that's the only one that we see right now. So we'll have to maybe work with something here in just a second. We'll see what happens. So when I put my 1 in, I get this right here. I get 1 squared plus 4 times 1 plus 1 equals a times 1 plus b times 1 minus 1 plus c times 1 squared plus 1. Looks like that. And 1 minus 1 is 0, so this guy goes away, and I'm left with 2c equals, and then on the right hand side, or on the left hand side, I've got 6. So I know that c equals 3. Okay, and I'm going to use that to help me solve for another 0. And again, I get to pick my zeros, and so I need another of these variables to go away. And so what I'm going to do is I'm going to let x now equal 0. Okay, so with x equals 0 and c equal to 3, I plug in 0 squared plus 4 times 0 plus 1 equals a times 0 plus b times 0 minus 1 plus c, which we learned is 3, times 0 squared plus 1. And again, some stuff happens on the left. Everything goes away except 1. On the right now, notice that the only variable I'm going to have left is b. Negative b, okay, plus 3. And so when I look at this guy, then that's going to be negative b equals negative 2. So in this case, b is 2. All right. Well, to get that last guy, we borrow this trick again, and we pick another value for x. So I've used 0, I've used 1. You want to pick something that's not going to be super difficult. And so you might just say, I don't know, x equals 2 to keep your numbers positive and small. And now remember, b is 2 and c is 3. So now what I'm going to do, I'm just going to have 2 squared plus 4 times 2 plus 1 equals a, I don't know, times 2 plus b, which is 2, times 2 minus 1 plus c, which is 3, times 2 squared plus 1. So just work this guy out. And on the left, you're going to have 4 plus 8, which is 12, plus 1, which is 13. And then you're going to have 2a plus 2 times 1 plus 3 times 5, 15. And so 13 equals 2a plus 17. And when I move that 17 over, I get negative 4 is equal to 2a. So my a equals negative 2. That gives me an answer, and I'll write it in red, of negative 2x plus 2 over x squared plus 1 plus 3 over x minus 1. This guy's going to be a toughie. He's an irreducible quadratic squared, so we're going to have ax plus b over x squared plus 1 plus cx plus d over x squared plus 1 squared. So when we do our math here, we're going to have an x squared plus 1 that we need to add with that ax plus b part. And what that's going to give me then is 2x cubed minus x squared plus 5x equals x squared plus 1 times ax plus b plus cx plus d.
Okay? And this is a tough problem because now there's actually no way we can get to a 0. And so one of the little tricks that we can use on this particular guy is to look at the different terms of our problem and see if that helps. And what I mean is, if you look over here on the left, I have 2x cubed minus x squared plus 5x. So on the right, let's FOIL this out a little bit and kind of regroup it. And so I'm going to have ax cubed plus bx squared plus ax plus b plus cx plus d. And so all I did was FOIL out that first guy. And now, I only have one cubed term right here. I only have one cubed term. Well, if 2x cubed equals all of this stuff over here, and I've only got one cubed term, then a has to equal 2. Okay? The x squared term right here, see this x squared term right here, there's only 1. The x squared term right here, there's only 1, and it's a -1. So that b has to be a -1. And once I've gotten to the point where I've got one of my coefficients established, then what I can do is go back to what we did on the previous slides. So now I'm going to run through here and I'm going to say, all right, what happens when x equals 0? I pick something simple. When I put 0 in, it should knock off one of the variables I don't know and just leave me with one left over. So now I'm going to have 2 times 0 cubed minus 0 squared plus 5 times 0. And that's going to be 0 squared plus 1 times a, 2 times 0 plus b, -1, plus c, which we don't know, times 0 plus d. And what ends up happening is I'm going to have 0 times all of this. So this guy's gone, and that just leaves me with that d part. Actually, this will be a 1 right here. So what I'm going to have is 1 times -1 equals 0 plus d. So my d is going to be equal to 1. And then to solve for that c, I can pick another value of x now, like say 1. So that's going to give me 2 times 1 cubed minus 1 squared plus 5 times 1, which is equal to 1 squared plus 1 times 2 times 1 plus -1 plus c, which we don't know, times 1 plus d, which we know is 1. Okay, and so now the only variable I have left, the only variable I got left is that guy. So now it just becomes a little numbers game here to solve it out. So this is going to be 2 minus 1 plus 5, which is going to be 6. And this is going to be 2 times 2 minus 1 plus c plus 1, which is going to be 3 plus c. And so c is equal to 3. And now I've got my partial fraction ready to go. So my partial fraction decomposition on this guy is going to be 2x minus 1 over x squared plus 1 plus 3x plus 1 over x squared plus 1 squared.